We are at a Walmart distribution center. What is a distribution center? Well, it's a place, it's basically a giant warehouse where products, which is a key term, and goods are brought to and stored here for delivery to the Walmart stores. So that's what these trucks do. They load these trucks up and they send the products and the goods out to the stores in a defined area. That defined area is also a very important phrase because I'm going to tell you how that relates to math. Everyday low scores? Not anymore. No mas. I am going to use this Walmart distribution center situation to help you understand something in math. I'm pretty sure that you'll be successful if you watch this video. By the time you get to the end, I think you'll have an understanding of it. And if you don't, well then I suggest maybe just watching somebody else's video or listening to your regular teacher at school, because I don't really have anything else. This is as deep as it goes for me. This is it. I'm gonna max out myself on this one. But what I'm gonna do in order to help you understand it is I'm going to use some of the world's leading, most cutting edge technology in order to demonstrate to you how this relates to math and how you can use it as a tool so that you don't really forget it. So here's what happens and how the products and goods get to the individual stores in a specific area from the distribution center. Now, the products are actually distributed to or brought to the Walmart distribution center. And then from there, they are redistributed to all the stores in a specific area. In this case, I have set up for you, this distribution center here is responsible for delivering to 5 different stores in this area. So all of these 5 stores will be getting products from this one particular distribution center. Now, how that occurs is, say this is a Walmart truck. This Walmart truck will load up the products and deliver to a store. Other trucks will be doing the same thing. Other trucks will load up products and they would deliver them to the other stores in a specified area. And this goes on all the time. Anytime you're out and about on the road, just look around, you'll see a Walmart truck, pretty sure. And this is what happens and how these products get to the stores. They all come from the distribution center, put on trucks, and then are delivered to each of the stores in a certain area. And in this case, the 5 stores that I have for you here all accept their products or goods from this particular Walmart distribution center. And that's how it functions. That's how it works. How did you like that display of technology? I'm a super techie. What else is there to say? Only that, to summarize the situation, the Walmart distribution center gets its name from the fact that it distributes the products from the warehouse to each of the stores in a certain area. And in this particular situation, I'm going to say that an area is going to be defined by parentheses. And what this pertains to is something we call the distributive property. It's when you distribute a term out to other terms. And I'm going to show you how to do it. I'm going to show you when you can apply it and when you cannot apply it. And in fact, in one aspect of this, it kind of contradicts the order of operations, and you may see it or recognize it. If you don't, I may point it out to you if I remember. But anyway, I'm gonna show you when you can use it and when you cannot use it. Here's how it relates to math. Let's say the term on the outside of the parentheses is similar to the Walmart distribution center. All the terms inside the parentheses would be the Walmart stores. So if this situation is like the distribution center, if the 2 is the distribution center, it's going to travel or take the products to each of the stores inside the certain area or inside the parentheses. So the 2 must deliver products to the 5 and the 4. This diagram shows that the 2 is delivering products to the 5. And in math, product means the solution to a multiplication problem. In this case, we're going to multiply the 2 with all the numbers inside the area. We're going to start by multiplying 2 times 5. Next, we would deliver the 2 to the 4. And since it's products, we would do 2 times 4. Here's how this plays out. We're going to do 2 times 5. Then we're going to do 2 times 4. Since we have an addition operation that we have not used, we're just going to bring that down with our products. Now we're going to use the order of operations to finish simplifying. 2 times 5 is 10. 2 times 4 is 8. 10 plus 8 equals 18. Now, let's compare using the distributive property with the order of operations. In the exact same problem, if we were to use the order of operations, we would do what's in parentheses or the grouping symbols first. 5 plus 4, which equals 9. Next, we would then multiply the 2 with the 9 because anytime a number is beside or next to parentheses, it means to multiply. And if we do 2 times 9, we get 18. The same solution when we used the distributive property. In example 2, I'm going to use the distributive property again to simplify this expression. I need to distribute the number or term on the outside of the parentheses to all the terms inside the parentheses using multiplication. Or I need to give out or distribute from the distribution center to all the stores in the certain area. So the 3 on the outside must deliver to all the stores inside the parentheses. I start first by distributing the 3 on the outside to the first term on the inside, which is also a 3. 3 times 3. That simplifies to a term of 9. Next, I'm going to give the 3 on the outside to the 2 on the inside using multiplication. So I will have 3 times 2, which gives me 6. I still have not used the operation inside the parentheses, so I'm going to bring that down to add together my 2 new products. We have just simplified this expression using the distributive property. The solution is 15. How does that compare with using the order of operations? Well, using the order of operations, we would first do what's in the grouping symbols. In this case, it's 3 plus 2, which is equal to 5. And since a term next to a grouping symbol means to multiply, we will then bring the term 3 down and multiply it with our solution from the parentheses, 3 times 5. Which simplifies to 15 as well. In this third example, I am again going to use the distributive property to simplify this expression. The number on the outside is the distribution center. I need to give out or distribute the products to all the numbers inside the parentheses, being the 6 and the 5. Since I'm saying products, I know that I must multiply the number on the outside with both terms on the inside. I'm going to give the 5 to the 6 using multiplication, 5 times 6. Then give the 5 to the 5 using multiplication, so I get 5 times 5. To finish simplifying, I must follow the order of operations now. 5 times 6 is 30. 5 times 5 is 25. I have not yet used the operation inside the parentheses, so I bring that down with me and I use it to simplify in the final step. 30 minus 25 equals 5. This is a side-by-side comparison of using the distributive property and the order of operations to simplify the exact same expression. Just remember that when using the distributive property, After you have distributed the number on the outside to all the numbers on the inside, you must then follow the order of operations to finish simplifying. In this fourth example, the only really difference is I've added an extra term inside the parentheses, which is just like another store in an area. The Walmart trucks would go from the distribution center to each of these 3 stores. So deliver the products to each of the stores. We are going to give the 2 on the outside of the parentheses to all 3 terms on the inside of the parentheses using multiplication. We will multiply the 2 with the 2, the 2 with the 3, and the 2 with the 4, and then bring down any unused operations inside the parentheses. Following the order of operations, we get 4 plus 6 plus 8, which simplifies to 18. You may have noticed that all the examples I've given you so far have a number or term on the outside of a parentheses. That always means multiply. You may have also noticed I've only had the operations of addition or subtraction inside the parentheses. This is because the distributive property can only be applied when there's addition or subtraction inside the parentheses. If there are any operations other than addition and subtraction inside the parentheses, you will not be able to use the distributive property. Here are some examples that look similar to my previous examples, but you will not be able to apply the distributive property because they each have either multiplication or division inside the parentheses. Regardless what side of the parentheses the outside term is on, you can still apply the distributive property